All right. All right. Welcome back. So we're on, I think this is lecture seven. I don't remember the exact lecture number, but today's topic is the mathematics of getting what you want in life. So, um, okay. So how do you get what you want in life? And how do we think about this mathematically? Well, let's take a look. Today, we're going to learn the mathematics of getting what you want. Now, believe it or not, everything in life, you can basically mathematically represent that thing or that concept, the idea, as either a matrix or a vector. Okay, so what do I mean by that? Well, let's say we talk about something you want, like getting a job after graduation. Well, let's look at this as an example and consider the important components to achieve this. Well, how can we achieve this? Well, maybe we need to graduate with good grades. So grades is a component, right? And you'll get like between 0 to 4.0, something like that. And then you want to between 0 and 10, you also want to impress the interviewer. Like you need to kind of know your stuff. So you need to get good grades to get the interview. Once you go to the interview, you actually need to know what you're talking about. And then also, will people want to work with you, right? If they don't, they look at you, they just don't like you, and well, there's not much you can do. So you also need them to kind of like you a little bit. Or lastly, it's like the economy, right? The No matter how good you are, if the economy is really bad, like it's kind of sometimes outside of your control. So you're not going to get a job. So basically, like you just kind of figure out, okay, there are some factors here, and in order for you to get a job, there's some kind of minimum requirement. And let's just say you pick, depending on the job you're looking for, the minimum requirement maybe is your GPA needs to be 3.0, right? And you need to impress them 9 out of 10, right? Pretty good, and that they like you, like 9 out of 10 like you. And the economy doesn't have to be amazing, but it has to be like functioning, right? 6 is good enough. So you can see that like this is what you want, and you can essentially kind of figure out how to construct what you want mathematically as a vector, right? And once you got a point, this is like we talked about before. It's kind of like a point in space, right? Here's a point in space, and then you are like here right now, and you're kind of trying to get from where you are at now to where you want your desirable destination, right? This is what you're trying to do. Okay. Now, represent like ideas and concepts as vectors is essentially how large language model work today as well. They look at numbers, and that those numbers represent like some kind of concept. And those concepts combine together to help large language model reason. Okay? So they basically large language model understand the world by representing every possible object idea into vectors. You may have heard of this thing called tokens, right? Tokens are kind of like words like hello my friend. So you can see hello is a token, my and friend. So they're kind of split into tokens. And what they do is they convert these tokens into vectors. So tokens ultimately just becomes vectors, right? So when large language models are reading stuff, they convert it ultimately into vectors so that large language models can understand them. And these tokens have very interesting properties, like vectors. And the property is if two concepts are like similar to each other, then their vectors should be close to each other, either angularly or L2 norm. However, if they are different ideas, they tend to be far away. And in some models, what they do is they kind of use vector summation to combine ideas. So, for example, you have a color black, which is a vector, and then a dog. So a black dog is essentially a vector from the combination. Not all models use this, but this is a possible way you can do it. So these vectors in machine learning are often called embeddings. or tokens, right? So I think in the large language model today, you may have heard of people talk about tokens, which ultimately just is just a vector. And so, for example, ChatGPT 5.0, I think the vector length is roughly 3,000 something. So this is how big of a vector they use to represent each like concept or object. Now we can view getting the job as a destination, right? It's some point in space, right? Like I said, here's a point, here's where you are, you're trying to get to your destination. And what we can do is look at the tools that's available to us as ways to reach the destination. So let's say grades, right? So grades, that's a vector. And then how much knowledge you have, that's another vector. Likability, right? They have to like you. And then economy. So the combination of these four factors times something combines together to help you reach your destination, right? So from this perspective, if this is our destination, we can pretty easily guess how much grade we need, right? We need this is a 3.0, right? So alpha 1 should be 3.0 at least. This is the bare minimum. And then knowledge, we know alpha 2, right? So alpha 2 is 9.0, right? And then 9, and then this should be 6. So we have tools available to us that we can use to reach our destination, and then factors kind of more outside of our control. For, from this formula, you can see that like a vector can be used to describe our destination, and vectors can also be used to describe factors and tools available to us to help us reach the destination. And then like even if we have the tool, we essentially need to generate these numbers, right? You know that you want to get good grades, but you actually need to work hard to generate the number so you actually get 3.0, for example. And also vectors can be representing situations outside of our control, like the economy, for example. That's the economy. Therefore, our goal is to combine things within our control, these ones, and then outside of our control, this one. And by combining the two of them, it allows us to reach our destination. Right? A single tool, like a single vector representing a method for us to construct the final goal, is called a basis. So each one of these is a basis. And collectively, all together, they're called the basis vectors. So all of them. Or they're also called the spanning set. But most, I prefer basis vectors. So that's the naming convention. And then these things are called coefficients, right? Just because, you coefficients are basically things that you need to generate, right? So I split the coefficients into alpha values and beta values. So the alpha values are another way of saying effort. You need to put effort in order to generate these values. Like maybe you're just likable already, so you don't have to put too much effort. But most of these you need some kind of effort. And the beta values are fate. That's just luck. Are you lucky? Are you not lucky? Did you happen to grow up in a place that you can utilize your skills? And you're born into these situations, basically. And together, I call these are called coefficients, right? The coefficients basically tells you whether you will reach this or not. Your goal to get somewhere in life, right? You can essentially systematically achieve anything by identify the tools. So you need to identify the tools available to you, and sometimes you may not have enough tools. Maybe you need to go back to school and generate more vectors, right? Maybe you need to do that. But the point is, you need to basically have the tools available to you. That's the first step. And once you have the tools available to you, then you need to then grind, like work hard to generate these alpha values. Like you need a 3.0. Okay. You do what you need to essentially generate these alpha values. And then this is up to luck. So there's not much you can do there. But you can create your own luck by controlling the parts that you have control over. Now, the equation of getting a job is a system of equations that we have been learning so far, right? So remember, there are four factors. We can essentially pull them out into a vector. So notice how this multiplied by this equal to this is mathematically equivalent to this. So what we have been learning of linear system is a way of thinking about how we can achieve goals in our life. And basically, I told you these systems are kind of like functions. You put something into the function, and then you get some kind of output, some kind of outcome. And this right here, we're gonna call them the input of your free will. Your free will and your actions basically will go into the system. And this system is the matrix. This is the matrix that controls like your life essentially. Like, of course, we don't know the exact number of the matrix, but we all know that you do something, something will happen, right? So the matrix is the controlling factor, right? And so this right here is the matrix, the matrix. Depending on how the matrix is constructed, it essentially controls the outcome of our action. And the matrix is essentially like this is like an invisible force that like that dictates cause and effect in everything we see around us. Right. So knowing the existence of matrix can really help you in your life. You need to realize that the matrix, right? This matrix is mostly constructed by you. Right? The basis vectors are from your experiences, right? I mean, they're obviously vectors outside of your control, but majority of the vectors comes from you, right? As you go through, as you go to school, you gain life experience. You're essentially constantly building the basis vectors. You're constantly just building the basis vectors, and as the basis vector gets larger and larger, like what you can achieve becomes bigger, more and more. There are more things that you will be able to achieve. So, so what you need to understand is that the matrix is not static. Like right now, you may not like your current situation. Maybe you're not happy with something in your life, but you just have to identify a destination and rebuild your bases and like walk towards it. It takes like grinding. You have to grind, but you this is basically how mathematically you can get there, right? And ultimately, you do have the power to change the matrix. It's not You're not powerless. The matrix comes from you, in fact. So we all understand, like intuitively, have some kind of understanding of cause and effect. And your understanding that the matrix exists, like, could be accurate or flawed, right? Like your understanding of the reality could be very flawed or very accurate. And it then dictates how good you are at predicting your actions outcome. And the truth is, most of us are pretty bad at predicting the outcome because they are unaware that the matrix exists. And we all know that some people constantly make bad life choices. So that kind of tells you most people are unaware of this idea of cause and effect. Now, the matrix we just saw, if we put it in the augmented matrix, it will look like this. And the coefficients are really easy to find because it's already in the RREF form. However, I mean, life is kind of messy. It's not always already in REF. And in sometimes the matrix is more complicated. And in those cases, you need to find a coefficient. So that's where Gaussian elimination comes in, right? So, well, we can also do the inverse right? A inverse A x equals to x inverse y. We learned that last class. So basically, you can use Gaussian elimination, or you can use this, and this will tell you the coefficients, right? Given what we already learned about linear systems, remember there are three possible outcomes. Three possible. There's a unique one, right? There's a unique solution, and then there is no solution, and there's infinite solution. Those are the three. So unique solution means that you already have all the tools available to you. You just need to generate the coefficients. You just need to generate the alphas. Once and generating alpha is a lot of work. Just because you have the tools available to you, it doesn't mean you can make your dream come true. You actually have to like take your steps to get there. So that's if there's a unique solution. And then there are ways there are no solution. That means among your equations, you have contradicting desires. There are things that are just not possible. Like you can't live in California and Boston simultaneously, right? So that's an example of no solution. That's just in what you want is it not possible. And then there are infinite solutions, right? In the case of infinite solutions, that actually means that you don't have the tools yet. You don't have the tools. All right. You need to actually go back and figure out what is missing and then build your tools. Right. Remember, when we had infinite solution, that normally means that you didn't have enough equations to solve for the variables. Okay. So in this analogy, it's similar to you basically not having enough bases. So from this perspective, right, the purpose of you coming to college, like you coming to my class, is basically like to develop new basis vectors. So that you are changing your matrix constantly, and you will essentially make what was impossible before, and after class, hopefully it then becomes possible because you've changed the matrix. Like, hopefully that makes sense. All right, so let's quickly practice this idea. Let's say let's say you want to get an A in Professor Wu's class. We call this target, and we have three ways to achieve this. Um, X1 is to come to class. X2 is focus on homework, and X3 is to really focus on gaining an intuitive understanding. So these are the three vectors, right? These are the three tools available to you, and reach you want to reach this destination. Okay, this destination. See if you can solve for the coefficients you need for each one of them. Now, the coefficients, the larger the coefficient, the more effort you have to put in. Okay, so this basically tells you by looking at the coefficients, solving for coefficient, you can figure out what's the most important thing. Okay, you solve this by pause the video, solve this by Python, and definitely solve this by hand. When you have the chance when you get home. This is a good exercise. Okay, over here is the solution. I solved it by hand. Python is pretty easy. It's like 2 lines. So okay, so I'm going to continue. All right, so now that we understand the concept of D matrix, as well as like how to reach what you want, we can now talk about this idea called the span. And I'm going to represent this idea using this in the class. We'll play a game, but over here I'll just show it to you. Let's say we have a student, we have a boy, and that really likes the girl. And one day the boy sees her in a party, and then the boy essentially decides that like he's going to go and try to get her phone number. Like so 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 in the first situation, the student, like the boy, doesn't know how to talk to girls and doesn't know like much about like what to do. However, he learned one single tool. And the single tool, we're going to represent that as a vector x1, which looks like this. And this tool is called flattery. Basically compliment. Like say something nice. And let's say that the girl, in this case, destination is here. That means if the boy give one flattery, this is at 2. Basically give 2 compliments. Like, oh, I like your hair. Your shoes is nice. Can I have your phone number? Right. So basically, this boy is capable of reaching the girl's heart, simply by having two compliments. So this is an example of reaching your goal using the tools available to you. Okay. However, that is if the girl's heart was here. However, if the girl's heart is over here, well, if the boy has one compliment, two compliment, I don't know, 1,000 compliments, right? You can very easily see that no matter how many compliments the boy give to the girl, the boy will never ever reach to be able to get a number, right? That never, right? Because the boy can only give compliments. That's all the boy can do. So as long as the girl is somewhere along these lines, then the boy can reach them given enough effort. However, if the girl is somewhere else, in this case, in a different dimension, like there's zero chance. The boy can never ever reach. So in this particular case, we say that the girl's heart is in the span of the boy's capability. All right. Span is a point given the tools available to you that you can reach. That's what a span is. Again, a span is a point. So any point here is within the span, right? Because the boy can reach it given enough effort. However, in the second case, the girl's heart is not in the span because no matter how much effort the boy puts in, the boy will never, ever, ever reach her heart and therefore never get her phone number. So that's the idea of span. Span, if it's in your span, it means it's within reach, that given enough effort. If it's not within your span, no matter what you do using the tools available to you, you will never ever reach your goal. And that's the idea of span. All right, so when you don't have enough span, what do? You go back to the drawing board. So after not getting the number, so the boy didn't get the number, the boy goes back to the drawing board, and then he learns two more techniques. One is called humor, and the other one is flirting. Okay, so we have humor, which is another vector, and compliments, another vector, flirting, another number. Now, notice that humor and compliments are independent of each other. And when I say independent of each other, it means that no matter how much humor you have, notice you can never generate compliment, right? You will never ever reach compliment. And then compliment, no matter how many compliments you have, it doesn't mean you're funny, right? However, notice how flirting is a combination of some humor as well as compliment. So therefore, the two of them are independent, but flirting is dependent on both of them because flirting can be reconstructed using some humor and some compliment. Okay, so now that we've increased the tool set available to this boy, is it now possible to reach the heart? Yes, there are many ways now. Notice how you can give some compliments and then you can give some humor. So say something funny. Humor. So you kind of talk to them a little bit, say something funny, and can I have your phone number? Right. Or or you can even do compliments. And then so this is compliment. And then you add some flirting, right? Flirting is in this direction. So you do compliment, you do some flirting, and then bam, can I have your phone number? And I mean, there are many ways. You can even do what else can you do? You can be serious. So instead of being like, oh, funny and silly, you can be serious. So let's go in the negative direction. Serious. But you're seriously really interested in her. So you put some flirting in there. So you're serious, but in a way that like is respectful and that they really like you, then that could also reach. So notice how through these combinations, all these various combinations, the fact that we've increased these tools, the heart is suddenly like reachable. Right? You still have to work at it, but it's not possible. Right? It doesn't have to be easy. It's just possible. And that's why span, like it becomes, adding tool sets makes what used to be impossible possible. Okay, so the span, right, is the space of all possible accomplishments you can achieve currently, right, with the current basis. This, your span is constantly changing, right? If the goal is within your span, you can achieve it. If it's not within your span, there's nothing you can do unless you increase your basis. So increasing basis is the name of the game, right? Now, here are some examples how to increase your span. Notice if you just increase your knowledge, like if you just come to class, you're increasing your knowledge, you're constantly increasing the size of your span, right? Or you just make some friends. Don't be an ass. If you're like a really good guy and you have lots of friends, they are, each friend is a new basis. uh, and you can, like, this is why networking helps so much, because it expands the possibility. Like previously you didn't know this guy, and now this guy helped you get a job. You know, having friends and being liked, it's very, very useful, and it increases your span dramatically. Now, you can have redundant vectors. So notice that you didn't really need flirting, right? The guy didn't need. You can essentially just use humor and compliment, right? Or compliment humor. Either way, you can already reach the heart, and that is because the heart is in 2D, right? So as long as you have two vectors like this, right? Even if you have flirting and compliment, you can still reach the heart because it spans a 2D space. Previously, if you only have one tool, that only span one dimension. You have two, it spans two dimensions. However, just because you have three, it doesn't mean you span three dimensions. You have three tools, but you still are stuck in this two dimension. Nothing is sticking out, right? Nothing is sticking out. So this is why I said flirting in this particular case is is adding to your tool, but it's not increasing the size of the possibility, right? Is so what we call the dimension created by your basis is called the rank. So in this particular case, the rank is two. You there are only two dimensions, and then and we tend to represent uh, the basis vectors like such, okay, as V transpose. All right. So personally, understanding the matrix and the span, honestly, is the meaning of life for me. For me, I mean, I don't know about you guys, but when I was young, I basically asked myself, if I'm about to die, what are the top five things I want out of life? Okay, and this was my answer. Number one, and these are orders of importance. So I will always pick the top one over the bottom one. But the top five is love. Love is the first one. What I mean by that is, like, I want to have like a family I love and good friends that I love, lots of good friends, and I feel like that is ultimately like what I care about the most. And second is time, right? Well, I want to have time to spend with the people, because if you have loved ones but you can never spend time with them, then it's kind of useless. So I want to have time, and I want to have time to kind of do things I enjoy, right? I like to do some hobbies. I like to have time to relax. So time is, to me, the second most important. And the third one was financial independence. And I don't want to have to like work constantly, and that kind of goes into the idea of time, right? Once I have financial independence, it kind of buys me time. I can use money to buy time, and I want to have enough, so hopefully one day I don't have to work anymore, right? And number four was intellectual capability. I mean, I could have all these things, but I don't want to be stupid. So uh, love is more important, yes, but once if I can achieve these, I also want to be relatively intelligent. And the last one was that I want to help others to also help them achieve their dreams. So these for me are the five, right? So this right here is essentially a vector. So to me, like basically my life is to achieve these five things. And then once I have once I have this vector, I basically spend every second of my life building basis vectors to achieve them. So I'm either grinding to generate the alpha values. Remember there was the alpha and the beta values. I'm always like grinding to generate the alpha value so I can achieve these. Or I'm building new bases to help me achieve them. And so you can see that I don't know the exact number of the vector, but somehow by understanding the matrix, it kind of tells me exactly what to do with my life. Like with my life, well, there's a vector, and then I'm just trying to get to it, right? And if you look at life this way, and if you look at life this way, basically, it becomes clear, like what is it that you should be doing, right? Like what is you once you decide what you want, you know what you should be doing to reach it. Otherwise, like everything else just kind of feels trivial because they're just kind of like distractions, right? So when you go home, like take some time, think about your top five. What is it that you really want? And once you realize your top five, you may start seeing things you're currently doing that's not really helping you to achieve those top five. Okay. So, anyways, that's a lesson for matrix, the matrix, and span. Let's now actually focus more on the math portion. The math definition of span, like let's say you have a vector that is transpose a vector that basically you have these bases, right? All these are bases, and you're trying to find the span of this. What is the definition? Well, if you have multiple vector v1, v2, v3, right? Depending on your alpha value, alpha 1, alpha 2, alpha 3, you generate a point. Okay? Now you have another one, you generate another point. So depending on your alpha value, you're kind of generating a different point. You're like reaching a different goal, right? So you can imagine as long as you can change alpha 1, alpha 2, alpha 3 to any number, and you're going to generate a different goal, different destination. This right here is the mathematical definition of span. Everything that is achievable with your basis vector right now. And that's what this is saying. You for any alpha 1, alpha 2, alpha 2, 3, all the possible points you can generate by combining all the tools available to you. Okay? So that is the mathematical definition of span. And the question is, can you identify if a point is in the span? Well, that's super easy. Like, let's say you have this point and you want to know if it's in the span. Well, guess what? This is the Gaussian elimination again, right? As long as you can come up with alpha 1, alpha 2, alpha 3, as long as the number exists such that you can reach your goal, then it's in the span. Like that's it. Like so Gaussian elimination, you can see we keep going back to it. You need Gaussian elimination to solve like all these things. Okay. Also, I remember I told you previously that just because you have three vectors, it doesn't mean it's going to span three dimensions. Sometimes we have three vectors, three tools, and then you only generate two dimensions. So how do we find out, like if you have 100 tools, but what is the dimension, right? Remember, the dimension is the rank, the exact number of dimension. And that's actually really, really easy. You simply identify the RREF and the number of the leading variables is your rank, right? So it tells you exactly how many dimensions you're spanning. Okay. So wait a second. Oh, yeah. So this is how you find span. And here's an exercise. Like, see if you can find the rank for this case. I have the solution here. All right. Now, when you solve for the rank, you don't really need the label. You can actually just do REF here and forget about the augmented part. And then you can basically just count the number of leading variables. And that's your rank. In this particular case, the rank is 2. All right, let's practice this concept. Given the following matrix, see if you can solve this problem. Pause the video. I'm going to continue. Here's the solution. Here's the solution. Okay, now it's linear dependence. Wait, how much do I have for this day? Okay. Wow, this is a long lecture. Okay, let's continue. Linear dependence. As mentioned, okay, just because we have more vectors, it doesn't imply we got a bigger span. You could have a lot of redundant stuff, right? But redundant doesn't mean it's not useful. So, for example, if her heart is here, right, it's faster for you to achieve it this way rather than this way and then this way. Okay, so like I don't want you to think redundancy is necessarily bad. It just allows you to do certain things even faster. So the idea of redundancy is related to linear dependence. So what exactly is linear dependence? Well, linear dependence is a mathematical terminology to describe like when two vectors exist within another vector, right? Another way to think is that if they're linear dependent, you can use vector within the basis to reconstruct other vectors. So notice how now flirting is like redundant, right? So we can actually use humor and complement to reconstruct it. Therefore, if you can reach this point using humor and complement alone, then this is redundant, right? So, and therefore this is linear. So these three vectors are linear dependent because there are ways to reconstruct it. So what is the test when you're asked about linear dependence? The test is a set of vectors, right, basis vectors, are linearly dependent if and only if there exists a non-trivial solution. Okay, so basically, if you just add them up, if you just remember, these are the basis vectors. If there exists a solution such that it gives you a 0, that's non-trivial. So obviously, if you just multiply 0, 0, 0 to everything, it's going to give you 0. So imagine a set of solution that is not 0 and that you can use it to reconstruct it. Therefore, to run this test, you simply need to solve the Gaussian elimination. Again, when you solve the Gaussian elimination, you set the solution to 0. If the solution is 0, then it's linearly independent. Otherwise, then it's linearly dependent. Okay? So this right here is this is a bit of stuff to remember, but let's see if we can let's just practice it. Okay, is this it? Yes, that is it for today. So practice this idea of linear dependence, identify the rank, and I think that's it for today. I'll see you next time.